Uh, this chapter, we're going to talk about frequency distribution. Uh, Before that, just want to explain something. A theory is different from a law. Okay, a law is 100% accurate. Every time you test it, it happens exactly the way you predict. So, for example, the law of gravity. You drop something, when you let go, it always dropped. It's 100%. Yeah, there's no exception, right? Unless it's the other factors. I mean, gravity is always there. That is a law. Theory, on the other hand, is a general guideline. For example, a map. A map will not show you a tree in the corner, how big is the mall, but it helps you to get from A to B, right? Um, so in the statistical theory, there are assumptions. We assume that the world meets some certain conditions, so we are safe to analyze the data we collect and make some conclusions. In reality, those assumptions are never 100% true. Okay, so for example, when I was in college, I learned about the statistics like a normal distribution of things, and I was, surprised. I thought, wow, I mean, the mystery of the universe is being solved. And this is so amazing. And later, I learned, oh, those are just assumptions. So it's kind of like my life is a lie. But anyhow, we're going to learn something very, very important, the basic cornerstone of one of the most basic concepts, normal distribution. So we assume everything we observe or study is normally distributed, and I believe that most of you are familiar with this concept. But let's take a look at this. This is, of course, the normal distribution. So we can study anything. For example, people's height, right? So this line, this axis, will be people's height from short to tall, right? And you will find out after you collect the data, like 100 people, you'll find out most of people are average. And this is the idea, few people are extremely short or extremely tall. And we call this, it has another name called bell curve, right? Now, in reality, it never happens 100%. However, it's a very good guideline for us. When we collect the data, you see, this distribution actually is a shape, like a triangle or square. And because it's a shape, we can calculate the area, the percentage, which can be translated into probability. Okay, more about that later, but this is a basic concept. Because by this assumption, it helps us be able to calculate probability, right? That's what I say. So we'll learn how to display frequency distributions. For example, we measure 20 people's heart rate per minute. Those are the data, right? Now, the first thing is we can do a dot plot. First, we find a range and display all the data on a line, and each dot represent a number. So for example, like this. This is a line, and I just by eyeballing and see what the minimum value is around 50 something, right? Um, so I start from 55, right? This is probably the lower of that. And the extreme value, the highest value probably is 90 something. So there's no absolute rules on this. It's just draw a line and set up the value. Now let's plot the data. So the first value is 70. So you put a dot on here, right? And then 71, and so on and so forth until you get all the data right here. Now you can see, I mean, approximately, because it's 20, I mean, the number is very small. But still, approximately, you can see it's a little bit like a normal distribution with most of people in the middle and few people in the extreme values, right? All right. Let's translate it into frequency table. Now you need to find the range. If you enter into Excel, it's very easy to find a range. But anyhow, I mean, only 20 people, we can eyeball in, no problem. The minimum is a 58, maximum is 82. Now 82 minus 58, you need plus 1 because we need to count 58 as well. Equals 25. Okay. Now decide the interval size. Now there's no absolute rule, as I said, and I'll use just 5 because the range is 25, so 5 count makes sense. So it looks like this right now. Look at this. We decide the smallest interval is 50 and 56 and 60, right? And there are 5 values in this interval, right? And each has 5 values. Right? So this column is an interval. This column will be frequency, and the third will be percentage. Now we count the number within each interval. So how many values in the this interval between 56 and 60? And if you just look for it, you'll find probably only 1. Right. Now between 61 and 65, well, there's only 1. Okay. Now I want you to pause the video and fill out all the rest of the blanks, and then we'll discuss. All right. Let's come back. This is my calculation. Okay, here. Compared to your table, your values. See if that's the same. Okay. Now we calculate the percentage within each interval. So for this interval, there's only 1 value, and in total is 20. So 1 divided by 20 is 0.05. And this, of course, will be the same. Okay, now pause the video and calculate the rest. Okay, now let's take a look. Right, that's it. Now, if you want, if necessary, you can calculate a cumulative percentage as well. So for example, you see, you will add another column and say cumulative percentage. Now the first one is still 0.05, but the second cell you're going to say 0.10 because it's these two combined together, and then the third will be 0.4, right? Because it's these 3 plus together, and so on and so forth. And finally, we can construct a histogram, which is commonly used. First, we decide a midpoint for every interval. In our case, it's a 58, 63, 68. Let me show you the table again. So here, this interval, the first interval, 56 to 60, the midpoint is 58. Now, 61 to 65, the midpoint is 63, and so on and so forth, right? All right, now we draw the x-axis and label it. The variable, for example, the heart rate in our case. And then the y-axis labeled as frequency. Now, x is anything you study, but y is always frequency. Okay, and then draw each bar for each midpoint. So like this. X-axis is heart rate. Now, if you study people's height, then this will be height, right? If you study how much they like pizza, then this will be how much they like pizza, right here. But here, well, this y-axis will be always frequency. And then you calculate the frequency, right? So 58, in this interval, there are only 1 value, yeah. Here only 1 value, here there are 6, and so on and so forth. And then from seeing this, you probably say, hey, this looks a little bit like normal distribution. And a little bit is probably enough. Now, this histogram is generated by Excel. And in chapter 1, lecture clips, I already show you how to use Excel to come up with some histogram. So you can go back, and if you don't understand how to do it, go back and review that video again. Okay. All right.